Last class, we plotted some data, and sometimes our data look like this.
Scatter plot.
And then we found in our calculator the curve of best fit, and if it was going upward, we called it exponential growth.
Model.
So one of the exponential growths that we did is when we folded the paper, it doubled every time. So 2 times 2 times 2, stop talking, times 2 times 2 times 2 gets really big, really fast, right?
Yes.
Now the other thing we did area of the paper and number of Skittles or M&Ms facing up. And we started out with a lot of M&Ms, right? But we ended up, after one dump of the cup, how many were left? About half-ish, right?
Yes.
And then about half-ish, and then about half-ish. And what did we call that downward curve?
Exponential decrease.
Close. Exponential decay. Okay? So those are our two types of exponentials, growth or decay. Okay? So today, we're going to kind of do our applications of exponential growth and decay, which are super important in the real world and very applicable to what we're doing right now. So, a very common place that we see exponential growth and decay is in the world of finance, so business and all that stuff. Underline this: compound interest. I'm sure you've heard of it before.
Yes. Heard interest.
Grows at an exponential rate. Because you get money, and then your interest is calculated off of that money. And so every time you get more money, your interest is calculated off of that new sum, and it gets bigger and bigger and bigger exponentially. So a couple words that you need to know. Interest is added to the principal, which is known as the starting amount. So if I ever ask you, what's the principal? It's however much money you started with. Okay? Compounding is this addition of interest and a principal. So you have a principal, you earn interest, and then you keep earning interest on the interest that you get from the bank. That is called compounding. The more money you have in the bank, the more interest you will make. So let's explore compound interest a little bit. For each compound interest problem, you'll need an interest rate and a starting principal. Here's your situation. Mr. Starks gets $2,500 as a graduation present from his grandparents. He puts the money into a mutual fund that earns 8.5% interest. Complete the table to see how much money Mr. Starks will have after 5 years. So,
8.5.
the starting amount is $2,500, right?
Yes.
Now, anytime you're using percentages, you'll want to convert them into a decimal. Now, I know this is a decimal, right, 8.5, but it's still written as a percent. So what do I do to convert a percent into a decimal, Jace?
You move the decimal.
How far and where?
2 places to the left.
Awesome. So 8.5% is 0.085. And that is the rate that we're going to be putting into our formulas. So you'll always want to convert the percentage into a decimal.
The interest rate earned will be that decimal.
Now, the next thing it's asking me is how much interest is earned. Well, how do you find the interest? If it's 8.5% of how much money I have.
Multiply the interest.
Yeah, you multiply them, right? So in your calculator, do $2,500 times 0.085, and that's how much interest I'll make the first year. And now, what are we always going to round to? It doesn't say it, but it should be common sense. 100 for money, right? Yes. 2 decimal places always for money. So I got $212.50. Is that what you got?
Yeah.
Now you should write the 0.
I got $21.
Do 2,500 times 0.085.
I did 200.
Will you just keep doing that?
So now, how much money do I have at the end of the year?
You
You
add
just
it.
you add them, right?
Whoa.
So $2,000, $2,712.50. And all I did was sit on my couch and eat Cheetos.
I'm gonna start doing that.
So how much money have I earned to date?
Mini money. $212.
The interest earned. So I have now made, by sitting on the couch and doing nothing, $212.50.
So the interest earned and the total money earned is the same thing.
For the first year. This is gonna, you'll see it here in a second. I'll do one more line with you.
Alright.
Okay, now let's do year 2. How much am I starting with on year 2?
2712.
Yeah, the final amount from the previous year. So $2,712.50. And now I have more money, right? So the interest that I make this year is going to be even more interest than I made last year. So once again, multiply the starting amount times 0.085, and it's going to be more than last year. That's called compounding. So how much interest did I make in year 2?
$230.56.
Awesome, $230.56. So what's my final amount for year 2?
You add that interest to
Good. Add those two together, and we get $2,943. I got 43.06.
yeah.
Now, the total money that I've earned is all the interest you've made so far, all the way back to the very beginning. So now we're going to add up this interest and this interest, and that's going to go here. That's the total money that I've made by doing nothing. I've literally sat on my couch in college and eat Cheetos. I didn't even go to school. I didn't even go to class. 2 years. That's all I did.
$443.56.
You like
You'd be 06
That's not right. You shouldn't tag me.
Okay, I want you to finish this chart off and see if we can all get the exact same final amount for year 5. Go.
What happens if we do this?
The Powerball. So here we go. The correct answer is $.
Yes.
Yes.
You got the $sign?
Hey,
Yes.
there's two
100%.
slashes through the
Three.
3.
7.
The next number in tonight's Powerball is a 7.
5.
How many of you have a 3 and a 7?
No whammies.
Going good.
No
Going
whammies.
good.
No whammies.
And then a 5.
5.
And then a 9.
29.
And then a 1. And the Powerball for $800 million.
It's a 4.
We won it too!
We won it!
I got 7.
Which means, by eating Cheetos and sitting on the couch, I have made $1,259.13.
That's
And that's in 5 years.
That was kind of a pain in the butt, right?
Yeah.
And that was only 5 years. So what if I asked you when I retire? In 35 years. Okay? So when we need something more than 3, 4, 5 years, that is why we have equations and models. So our first model for today is our exponential growth model. And it is y equals a. And what is a?
The original amount.
The original amount. Now sometimes in formulas, you'll see instead of an A, they'll put a P. But what does P stand for? What does P stand for in finance? The principal. So A, amount, P, principal, same thing. Plus, 1 plus R, once again, is the rate as a decimal. That's big, as a decimal. And T is obviously time. So, down at the bottom, we have use the exponential growth model to predict how much money I'll have in the account when I retire at age 65. So let's fill out our formula. Y equals, and then Faith, what was our principal? The A value, the starting amount.
2500.
2500.
Oh, you said that.
That's A, parentheses, 1 plus What's my rate as a decimal?
0.085.
0.085. Close the parenthesis, and t is time.
Oh, 9.
Now time is not 65. Why is time not 65?
Because you're 18 when it started.
Yeah, it said when I graduated at the age of 18, and now I'm 65. So correct, it's 4. Yeah, so if I was 18,
47.
this should be a 47. Now this is easy cheesy lemon squeezy. You just throw it in your calculator the exact same way that you see it. So get out your calculator. We're going to go 2500 parentheses 1 plus 0.085 raised to the 47 years. Just kidding.
That's a lot of
I
money.
missed my point.
Yeah, you find adjusting those.
So just don't spend any of that and you'll be rich.
So 0.085.
What's the point of being rich?
That's what I got.
That gives me
It's a lot to wait.
Yeah. 115,645.
$115,647.89.
That's not a lot of money.
That's for like 47 years, bro.
Yeah.
Next page. A computer engineer is hired for a salary of $28,000, which is really low for a computer engineer. But it says if she gets a 5% raise each year, after how many years will she be making $50,000 or more? Set up the equation, and I'll show you here in a second. I want you to kind of check and guess because we don't technically know how to solve this yet. But let's set up what we know. So here's our formula. A is the final amount, or sometimes they put Y. A equals the principal 1 plus the rate to the time. So what is the final amount? Whatever we get on the left side of the equation, that's the final amount, right? So that's going to be $50,000 equals.
Or more, question mark.
And now the principal, how much is she starting with as a salary?
28000.
28,000.
Yeah.
1 plus
0.05.
0.05. Now, do we know time?
No.
No, we don't know time. Now, technically, we don't know how to solve this yet. We'll learn how to solve this with something called a logarithm in about a week. But for now, what I want you to do is check and guess. I want to see who can get really close to t. So plug in like a 10 and see where it gets you. See how close you can get to $50,000. So plug in the right side of the equation,
Somebody do 10.
and then see, kind of check and guess, and see how you can get to 50,000. This is also a good strategy for the EOC. You know, if you don't know how to solve it, try to start plugging in answers and get close to what the possible answer is. So I got T. Now, who remembers what this sign means?
Similar.
No, two squiggly signs.
Approximately.
About or approximately.
Similar.
12 years.
Seems good.
It's a little bit over, right? Isn't it like 50-something thousand?
Yeah.
But that's a pretty close.
That's a solid.
Now, in about a week or so, we're going to find out exactly how to solve this and get the exact answer. Okay, go ahead and do example 2 on your own. I would have put y equals, and then how many students does the high school currently hold?
1300.
1,300.
1,300, good. Times 1 plus
This is actually for high school. So
0.078. It is very close to high school, yeah. All to the 8 years. And this is just, we know everything, right? So just throw this into your calculator, your graphulator, and what do we get?
2,371.
2,370.
I got 2,371 students. So, After 8 years, is our high school going to be big enough if it's being built to a company 1900?
No.
No. So they're going to have to pass more bond issues and keep building around the high school to keep up.